Hello, this is the last video for chapter 1. Analytics has application in various industries from sports, healthcare, retail, etc. Let's look at an application in a retail value chain. Retail is a sector with high volume but usually thin margins. Customers' taste and preferences change very frequently. It is not easy to be successful as a business in this dynamic scenario. The stores need to be looking out at the changing demands and the market environment and be able to keep up with it. Even if they achieve market dominance once, does not mean that the company will be the leader for a long time. Think about major retailers like Amazon and Walmart and how much money they have invested in analytics initiatives to manage their supply chains. This figure here highlights some of the major components of a retail value chain. You see that on the left side is the vendor of the company, and on the right side you will have the end customers of this company. In between, we have various departments within the company which help with different functions starting from planning to merchandising all the way to order fulfillment and maintaining customer relationships. At each of these touch points in the retail value chain, analytics could be helpful to address critical needs. For example, while dealing with the vendors, the company needs to maintain its supply chain, optimize the cost of inventory, make sure the inventory is just sufficient to avoid any shortages or excesses, and minimize the unwanted costs. Use of analytics can help with a lot of these needs. Similarly, for the buying function, there may be a need to understand the trends and get an estimate of the demand. Going further downstream, on the customer side, the company may have needs to retain the customer, to understand what their needs are, and enhance customer satisfaction. Here are some of the ways in which analytics can help meet these needs. For example, in case of inventory optimization, analytics can help answer questions such as which products have high demand, which products are slow moving or becoming obsolete. So, forecasting the demand of fast moving items can help ordering them with sufficient inventory to avoid any out of stock situation. Then there is market basket analysis, which can answer questions like what products should be bundled together. This analysis helps companies to increase cross-selling or upselling of the products. If you shop on Amazon and any other online web stores, you would often see products recommendation of items which are frequently bought together. The background of that comes from market basket analysis. Another famous example is like in a physical store or a brick and mortar store. If you go to, let's say, Walmart, what products should be kept together on the shelves or nearby each other? So if somebody told you that put peanut butter, jelly and bread together or bundle them together, that makes sense. However, if somebody told you bundle beer and diaper together, that's not so intuitive. But it was found in an analysis that a lot of people buy beer and diaper together. So the reason could be that people, when they are just going to the store for just buying beer, maybe they need to pick up some diapers if they have little kids at home. Or maybe if they are actually going to buy some diapers, they may think, yeah, let's take some beer home as well. So those are the kind of not so intuitive bundles or results that you can get by doing market basket analysis. Well, there are several other applications of analytics in a retail value chain. We already talked about customer churn analysis to enhance customer retention. We'll see more examples as we progress through the semester. Now, big data and big data analytics have garnered much attention in the recent years. So what is big data and what makes it big? Big data is the data that cannot be stored or processed easily through traditional tools or means. The main characteristics of big data is 4 V's: volume, velocity, variety, and veracity. Volume relates to the sheer size of the data sets involved, with information coming from business transactions, smart devices, uh, industrial equipment, videos, social media, clickstream data. It is very commonplace for us to measure big data in terms of petabytes, exabytes, and the size is growing. So, big data usually has huge size. Velocity means data in motion. It refers both at the rate in which new information is being generated and to the speed desired or necessary for it to be processed to make timely and relevant decisions on the data. Now we expect the processing of huge amount of data like click streams and be able to respond in milliseconds or less. So think about if you open an Amazon website while you're looking at one product, within milliseconds, as soon as you load the page, immediately at the bottom it comes what other products you might be interested in. If that is not done during the time you load the page, it's useless information. So we are dealing with very high velocity of data. Variety of the data means that now we have data in many different forms than previously available. Variety is an indication of multitude and diversity of information sources that make up big data. Big data typically refers to the data that comes in many different formats such as structured data, unstructured data, clickstream data, social media data, posts, tweets, pictures, video, and a variety of other different forms. Another main characteristics which has come in light in the recent years is veracity of the data. What that means is that the data that we have now may suffer from low data quality issues such as inconsistent, it may not be accurate, we may doubt the trustworthiness of the data may be incomplete or have missing values, and we may not be able to use the traditional analytics techniques on this kind of data. So that was 4 V's of big data. Now we understand that storing big data is a challenge, but it is not the only challenge. Data is worthless if it does not provide business value, if we are not able to process it, analyze it, get some insights from it, and then make decisions. So data needs to be analyzed. How can we analyze such huge volume and variety of data in a timely fashion? That's a problem. Well, the traditional techniques used for analyzing data may not work on the big data, maybe due to sheer volume. And hence, techniques such as Hadoop, MapReduce came into being, and we will learn more about big data and these techniques later. Let's look at various sectors of the analytics industry. It is important for us to understand the ecosystem to identify who are the providers, what role do they play, possibly look for job opportunities. Maybe you would want to identify some investment opportunities, and it will help us understand the landscape of the future computerized decision support systems. So the ecosystem that is displayed here is represented in the form of a flower, and the components of the ecosystem are represented as petals. The components in the outer petals are usually the technology providers. The inner petals can be generally defined as analytics accelerators. The accelerators work with both technology providers and the users. Finally, the core of the ecosystem comprises the analytic user organizations. This is the most important component as every analytics industry cluster is driven by user organizations. Let's look at some of these providers. The data generation and infrastructure providers are a new group of companies that enable generating and collection of data that may be used for developing analytical insights. Some of the major players include companies like AliveCore, Apple, Google, Fitbit, which is now part of Google, which collect information from, let's say, healthcare data. Then comes the data management infrastructure providers. These companies provide hardware and software targeting the basic foundation of all data management solutions. Some companies in this cluster would include IBM, Dell, HP, Oracle, etc. Then we have data warehouse providers. These companies provide technology and services aimed towards integrating data from multiple sources. Companies such as IBM, Oracle, Teradata, which provide data integration services, are major players in this area. Then we have middleware providers. These companies provide easy to use tools for reporting or descriptive analytics, which form a core part of the business intelligence or business analytics employed at organizations. Companies such as MicroStrategy, Plum, SAS, Tableau fall in this category. Next, we have data service providers. Most of the data used by the companies for analytics is generated within the company. However, sometimes they need external data to be integrated. That's where these data service providers come into picture. Companies like Experian, Equifax, TransUnion, which do users analysis based on their credit, they fall in this category. And there are several other providers. Analytics-focused software developers provide analytics software for general use with data that has been collected in a data warehouse or another platform. Companies like SAS, IBM, Microsoft, Tableau, Teradata are also working in this area. Then we have application developer. They could be industry specific or general. These companies provide solution for a specific industry or a generic solution for that industry. For example, Cerner provides electronic medical record solution to medical providers. IBM has a fraud detection system for healthcare insurance industry. FICO Scores, which offers credit scores, can also fall in this category. Analytics industry analysts and influencers can consist of 3 types of organizations or professionals. It includes professional organizations that provide advice to analytics industry, such as Gartner Group, McKinsey Group, Forrester. The second group includes professional societies or organizations such as Informs that provide similar services, but they are membership based. And finally, the third category or the third group within this area is industry influencers or analytics ambassadors. Now, in a dynamic field like analytics, it is very important to acquire new skill sets and maintain competencies. Academic institutions and certification agencies can greatly help with this need. If you are interested in pursuing a career in this area, please consider taking relevant courses and certifications. If you need help with any of these, we can have a conversation. Regulators and policymakers are responsible for defining rules and regulations for protecting employees, customers, and shareholders of analytics organizations. Some prominent players are Federal Communications Commission or FCC, Federal Trade Commission, FTC, and International Telecommunication Union or ITU. Finally, we come to analytics user organizations. Obviously, these form the economic engine of the whole analytics industry, and without the users, there would not be any analytics industry to talk about. So that's all about the analytics ecosystem. That brings us to the end of chapter 1. If you have any questions, comments, or suggestions, please send me an email. Thank you.